Welcome to the video on integration by substitution and parts. So first we have integration by substitution, which we've talked about in a previous video. So when the integral can be rewritten like the following integral here, then the inside function g of x can be substituted for u so that it's possible to take the integral by hand. On exam papers, substitutions will be provided if the integral isn't in this form. So if it doesn't look like this, then they'll tell you what you need to substitute. For integration by parts, if a function is too complicated to simply integrate, integration by parts can be used to find the integral. So to do this, you would separate your integral into two parts, and you would call one u and the other dv. So you'll have u, du, v, and dv. These will both come from the original function, and when you do the integral, it'll be equal to u times v minus the integral of v du. So if you had a function like the integral of x cosine of x dx, we could use integration by parts for this one. So if there's a polynomial function, that one will most likely be used as u because the derivative will help it become smaller. So if you have an x cubed, squared, or even just a regular x value, that would be the best one to use. So we'll use this as u. So we have u du v dv. So in our x cosine of x, one of these will be u and one will be du. We'll use our x as u, and then cosine of x as du. So we take the integral of x to get v. So the integral of cosine of x is sine of x. And then we take the derivative of u to get du. The derivative of x is 1. So this will be equal to u times v, so x sine of x, minus the integral of v du, so sine of x times 1, so just sine of x dx. So now we can take the integral of sine of x because we don't have anything in front of it. So this will be equal to x sine of x minus the integral of sine of x, which is negative cosine of x. So this will become plus cosine of x and then plus c. So here we have our first IB practice question. It says solve the following integrals. So first we have the integral of the natural log of x dx. So natural log of x isn't one of the derivatives we've memorized, but this would be the same as the integral of 1 times the natural log of x dx. And we can try integrating that using integration by parts. So we have u prime, v, and v prime. So we'll use 1 as u. That way when we take the derivative, it's 0. And then v prime, we could put the natural log of x. But then we get to the same problem of needing to take the integral of natural log of x. So in this case, you can see that it was wrong to use 1 as u. So we'll switch it around and say that u equals the natural log of x. So u prime is 1 over x. And then we have v and v prime. So our v prime is 1, and the integral of 1 is x. So then we have u times v, which would be x ln x, minus the integral of v times u prime. So 1 over x times x dx, which just simplifies to 1 dx. So this equals x ln of x minus x plus c. So this here is your answer to part A. Part B is the integral of x squared times e to the x dx. So here we have two functions multiplied by each other, so we'll use integration by parts. So we need our u prime, v prime, and v. So this one is x to some exponent, so we'll use that as u. And then we'll use our e to the x as v prime. The derivative of x squared is 2x, and the integral of e to the x is e to the x. So this will equal x squared times e to the x minus the integral of 2x e to the x dx. So we still can't take this integral, so we'll have to do integration by parts again. So we'll have u prime, v prime, and v. We'll use 2x for u and e to the x for v prime again. The derivative of 2 to the x is 2, and the integral of e to the x is e to the x. So now we have our x squared e to the x minus this integral, which would be u times v, so 2x e to the x, minus the integral of v times u prime, so 2e to the x dx. So this will equal x squared e to the x minus 2x e to the x plus our integral of 2e to the x. You can pull the 2 in front of the integral sign, and the integral of e to the x is e to the x. And then don't forget plus c. So this one, it took doing integration by parts twice before we could get to the answer. And that's the answer to part B. Finally, we have part C, which is the integral of x sine of x dx. So we'll need our u prime, v prime, and v. We'll use x as u and sine as v prime. The derivative of x is 1. The integral of sine of x is negative cosine of x. So we have x times negative cosine of x, so negative x cosine of x minus the integral of negative cosine of x times 1. So this will become plus cosine of x dx. So this equals negative x cosine of x plus the integral of cosine of x, which is just sine of x, and then plus c. And there's your answer to part C. Now we have our second IB practice question. It says, find the following integrals. So first we have the integral of 2x to the 5th times 4x to the 6th minus 2 to the 6th. So we have some number times x to the 5th times something to the 6th. So we'll use this thing inside the parentheses as our u value. So u equals 4x to the 6th minus 2. The derivative of that would be 24 times x to the 5th. So to have 24x to the 5th here, we need to multiply it by 12. So we're going to put 1/12 on the outside. So this is equal to 1/12 times the integral of u to the 6th du, which equals 1/12 times 1/7 times u to the 7th plus c. We can plug in our x value and get 1 over 12 times 7, which is 84, times u to the 7th, which would be 4x to the 6th minus 2 to the 7th plus c. So there's our answer to part A. Part B is the integral of x times the square root of x squared plus 1 dx. So for this one, we can see that the degree here is 1 higher than the degree of this. So we'll use substitution, where u equals x squared plus 1. So du equals 2x. So we need a 2 in here, so we'll put 1/2 on the outside. So we have 1/2 times the integral of the square root of u dx, which is equal to 1/2 times the integral of u to the 1/2 du. So we'll add 1 to our exponent to get u to the 3/2 times 1/2, and then we'll multiply by 2 over 3 because we're dividing by 3/2. So those will simplify to 1s. So our derivative will equal 1/3 u to the 3/2 plus c. So we can plug in x squared plus 1 for u. So this equals 1/2 x squared plus 1 to the 3/2 plus c. And that's the answer for part B. So in summary, integration by substitution is when the integral can be rewritten like this integral here. Then the inside function g of x can be substituted for u so that it's possible to take the integral by hand. And on exam papers, substitutions will be provided if the integral is not in this form here. For integration by parts, if a function is too complicated to simply integrate, integration by parts can be used to find the integral. And you would do that by splitting your first one into u and dv. And then your integral will be uv minus the integral of v du. If there's a polynomial function, that one will most likely be used as u because the derivative will help it become simpler. And integration by parts might need to be used multiple times in a row to find your final answer. That's all for this video. Thank you for watching.